Hi, everybody. So in this video, I'm going to talk about the terms present and future value. So mathematically, it's not going to be a new concept. We're just going to apply exponential models to the context of finance. So let's start with the following example. Let's say you invest $10,000 into an account that has an annual interest rate of 6% compounded once each year. So that means you earn interest on your balance once every year. So at the end of the year, you earn your interest. So the question is, well, how could we calculate how much money that account is going to have in 5 years? And so since the investment is growing by a constant percentage, that's why an exponential model would apply here. So if the rate is 6%, that means the annual factor would be 1.06. So to calculate our balance in the next year, we would calculate what is 6% of 10,000. So that's like the 600. And then we add that to the original balance of 10,000. And then for year 2, we could multiply by 1.06 again, and then by 1.06 again. And so this is why an exponential model makes sense. And we could do this a couple more times to figure out what our balance is in year 5. But if we want to make projections far out into the future, then it's certainly useful to have a formula for this model. So in general, this would look like if I let B denote the balance in the account, that B is equal to 10,000, which is our initial balance. So that's the initial value, times 1.06 to the t. So our growth factor is 1.06. And so if I want to figure out what is my balance in 5 years, then I would substitute in 5 into the exponential power, and then calculate that our balance would be $13,382, and precisely, don't forget the 26 cents. So make sure at this point that you've got a calculator or Excel working properly that's able to calculate these exponents. Okay, so some terminology with that example. That initial investment that we put into account, that's called the present value. And the $13,382.26 that you'll have in 5 years is called the future value of that investment in 5 years. So in practical terms, these two values are the same. So if I offered you $10,000 today, or $13,382.26 in 5 years from now, monetarily, they're the same value. Of course, you might think it's best to get the money today. But if we're assuming all you can do is invest it in an account with 6% interest, then we would say the present value is 10,000 and the future value is $13,382. And again, that 26 cents. And one more example to end the video. Let's think about the following example. You want to start a college fund for a child that is planning to start college in 15 years. And so your financial planner tells you, okay, 15 years from now, we expect 4 years of college to be $350,000. So that's what you should have saved 15 years from now. And you can invest your money. We're going to invest in a money market that has an annual interest rate of 4.25%. And we're going to compound that once a year. So if hypothetically, you were going to create this account by making one deposit today and then just letting it accrue interest for 15 years, what would that deposit need to be? So the main takeaway from today's video is here's the formula to connect present value and future value. So the present value times 1 plus r raised to the tth power equals the future value. So on the left side, we have what we have today, and then we accrue some interest. And on the right side, that tells us what that investment would be worth in the future t years. So this problem, we actually are given what we want to have in 15 years. So we know what the future value of this deposit should be. And what we want to find is what's the initial deposit today. So we actually want to figure out what is PV, what is the initial deposit that we should place into the account. So hopefully we have values for R, T, and the future value, and the only unknown is the present value. So if we read through the problem, they're gonna start school in 15 years. So let's think about where we should slot the 15 years. So that 15 years is the time. So that goes in for the power. And this annual interest rate of 4.25%, that gives me my value for R. And remember, I'm gonna convert that to a decimal. And finally, this $350,000, that's what I need to have in 15 years. And so the only remaining unknown at this point is the present value. And so in order to solve for the present value, we can divide both sides of that equation by 1.0425 raised to the 15th power. And again, you want to make sure you've got your calculator or Excel or whatever device you're using. You don't want to do this in your head. To do these calculations correctly, this should come out to about $187,000, a little over that. So that's where we'll end things today. Give the Canvas quiz a look. And if you have any questions about this or the other homework that you submitted, we can discuss on Wednesday. Bye.